Hi everybody, this is another video about constructing polynomial functions. I really like this sort of problem. It's just a puzzle more than anything else, and we have to put all of the pieces of the puzzle together. So let's get started. We have to write a polynomial that has these properties, and there's a hidden assumption here that I didn't write down. We're talking about a polynomial with real coefficients, so we don't like the fact that there's a complex number here. All right, so let's get started. If 3i is a 0 of our polynomial, then x minus 3i is a factor. That's the factor theorem. Well, in a previous video called Polynomial Quick Facts, we learned about a conjugate pair theorem. If 3i is a 0, well, negative 3i is also a 0. And if negative 3i is a 0, x minus negative 3i, well, that's x plus 3i. That must be a factor. So that takes care of bullet point number 1. What about bullet point number 2? Well, we have an x-intercept, 2, 0. So that means x equals 2 is a 0, because the function value is 0. That's the definition of the term. So if x equals 2 is a 0, x minus 2 is a factor. But what are we supposed to do about this extra piece of information that there's either a local maximum or minimum there? So graphically, if you think about what happens, 1, 2. So there's an x-intercept at 2. But to have a local maximum or minimum at that point, well, there are two possibilities. If you have a maximum at this point, it means, well, the graph has to touch and then turn around. That's the only way you can be a local maximum at that point. If you're a local minimum at that point, well, the graph might look something like this. The graph comes down to that intercept and then turns around and goes back up. Okay, you can't continue going down across the axis because then that point wouldn't be a minimum. So in either one of these situations, it means that the graph has to touch but not cross the axis at the point x equals 2. Again, from the Polynomial Quick Facts video, that means that this 0 must be of even multiplicity. So this factor must have an even exponent. Now if we want to make that as small as possible, let's just put exponent 2. That's the easiest way to do it. That takes care of bullet point number 2. Bullet point number 3 says, well, the leading coefficient needs to be 2. This is the easiest bullet to fix. If you imagine multiplying all this out, the first term, you would have x times x times x times another x because we have exponent 2. So you'd have x times x times x times x is x to the 4th. But we want the coefficient to be 2. So instead of 1x to the 4th, we want to get 2x to the 4th. So let's just multiply the function by 2. That'll do the trick. And finally, the last bullet point. This is the hardest one to deal with, and we'll see why in a moment. So the y-intercept needs to be 0, 8. Well, let's see what the y-intercept currently is. So with our current function, if we plug in 0, we have this leading 2, 0 minus 3i. We have negative 3i, and then positive 3i, and then negative 2 squared. If you multiply all of this out, negative 3i times positive 3i is negative 9i squared, which is positive 9. And then we have 2 times 2 times 2. The square is going to make the negative positive. So 2 times 2 times 2 is 8. We have 8 times 9 is 72. Or why did I write 79? 72. There we go. That's the current y-intercept. So we need to turn the y-intercept from 72 to 8. Well, we know 72 divided by 9 is 8, but, well, you can't do this. You can't just divide the function by 9 because that's going to invalidate the third bullet point. We want the leading coefficient to be 2. So if we divide by 9, it's going to change that leading coefficient. So what are we supposed to do? Well, if you read the instructions, there's nothing that said we couldn't put in another factor just because we feel like it. We're not violating any of the other rules. We still have our zeros. We still have our local max and min. Our leading coefficient is still 2. But now you can see what the y-intercept is. So now, if you plug in 0, we're going to have one more number here. We're going to have 1/9. So the 72 turns into 72 over 9, which is 8. So that last bullet point, that's kind of tricky if you've never seen that before. But I like these little puzzle problems. Anyway, hope this video helped.